Hello? Okay. So, I'm Bruce. I work in MSRC Engineering. We used to be known as SWI, but they just recently rebranded it, so now we're known as MSRC Engineering. MSRC Engineering is the group that when people report bugs to us, when people report bugs to secure@microsoft.com, it gets a case manager, and it gets assigned to one of us, and we triage them, and we make sure that the patches are done correctly. So today I'll be talking about how to analyze target attacks with Office documents. However, before I start, this is the first time I've been to a European country, so this is also the first time I've been to CCC, obviously. So there are a lot of pretty interesting things. Yeah. So this is like probably the most unique event I've ever been to. The cool thing downstairs, the hacker space or whatever. If you guys are watching, great job. Next time an FNet server goes down or get owned, I'll know why. And for those of you who work in governments or whatever, hello. All right, and I want to thank Felix and Fukami and the rest of the CCC staff for having me here. You guys are great. So we'll start. So most of you are probably familiar with target attacks. So basically what people do is, these are not drive-by attacks or anything. Most of the time the attackers will have an idea of who they want to attack, and typically these are large corporations, and they figure out, they do reconnaissance on the victim. They figure out who they work for, what kind of work they do, and sometimes even like their reporting infrastructure, their organizational, where they are in the org. Like, for example, if they're a manager or a director and so on, and who works for them. And based on those, on the details that they have, they can craft a special document and spoof it so that it looks like it comes from somebody they know, and then they send it to them and they'll obviously open it. So it's been very popular in the last few years. You hear some of the headlines I was able to find. Security Focus and Computer World are most trusted sources for computing news. So it is quite popular, but there's not much technical, like a lot of technical details, or even how to analyze these things in the public. I'm not sure why, but today I'll show you how to do that. And also I'll be releasing a new tool to help analyze some of this stuff. So using Office documents as an attack vector is like one of the best attack vectors that you have, because one, everybody uses Office. If you work in a large company, everybody uses it. And so people, if you work in a large company, you receive, attachments every day, especially if you work in HR, people submit resumes to you, quite often. And so this is quite common. People, if you send them an EXE, obviously it gets filtered at the exchange, mail gateway. So most people, back in the days, you just attach a Trojan. It's like, hey, run this, and you get free, you win the lottery or something, like free porn or something, and people click on it. So nowadays, people, they block executables at the mail gateway. So that stuff doesn't work anymore. So the new style is you attach like a PDF or a Word document. And then, of course, these things are so natural. People receive them every day, so they just click on them without even thinking. I mean, I would do it. And a lot of these things they're malicious, right? So, and they're very difficult to detect. Everybody has, most large companies have antivirus and firewalls and all this blah, blah, blah at the border to try to protect themselves. But when Office documents come through, they don't filter them, because if you block them, like half your org might not work anymore. So it's very difficult to detect. Traditional perimeter security, like firewall or whatever, it's not adequate, it's not sufficient. And also there's a lack of tools and techniques on how to triage these things. All right. So before I go into the details of these attacks, I just want to say that in order to understand them at a concrete level, you actually need to understand the Office file format. Without them, you might still be able to triage them, but you won't be able to get it. You won't be able to understand it fully. So I'll start first by explaining the Office file format. And the file format I'm referring to is the binary file format, the one that we released the specs for in February of this year or something like that, thanks to the EU. Yeah. And so, and when before that, there was no public documentation, except for like the OpenOffice team. They did some reverse engineering, and they wrote some documentation about it. And it's actually quite excellent. So if you work for OpenOffice, great job. Yeah. So the binary file format is the file format that Office 2003 and below produced. In Office 2007, they don't use that anymore. They use the XML file format, because I guess it's in style nowadays. So anyways, and they follow this, the file format is called the structured storage file format, and it implements compound files. And all it is just a file system inside a file. So you know, like SQLite, you have a SQL database inside just like one file. This is like a file system inside one file. And so you have the concept of directories and files. So except they're not called directories and files. They're called storage and stream. So storage is the equivalent to a directory, and a stream is a file. And each Office application stores its own data in a specific stream or storage. They'll give it its unique name. And when Office parses these documents, it just opens it up, figures out what the stream names are, and it reads those streams. That's pretty much it. It's very simple. Parsing it by hand is like not difficult, but it's annoying. It's difficult to make a good implementation of parse it from scratch. And this is why we have a COM API. We have COM API to deal with these files. Oh yeah, before I go on, so OLESS files are not only used by Office, they're actually used like MSI files, OLESS. Like a lot of third-party applications use these things. So it's not just Office. And most people, you shouldn't be writing your own OLESS parser. So we provide a COM API for you to do that. And basically all you do is you call a function called like STG open storage, and you pass a file name. And then you tell what kind of mode you want to read it in, like read, write, blah, 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 blah. And then you enumerate all of these storages and streams. And then you can go through them and you can read them. This is very similar to, like for example, in Unix you have open, read, and blah, 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 blah. It's the same thing, except for it's in Windows. Yeah, so this is an example of in how to use the COM API. But if you don't know C or C++, which that's only probably like 1% of you guys or something, you can use Python. I actually like Python a lot, so yeah, go Python. Python has, there's a class called Python COM, and part of that is just a port of, it calls the Win32 API. And so it's the same function names. And all you do is you pass the file name, enumerate elements, and you iterate through, it passes you back a list, and you iterate through it, and you read or write from it, do whatever you want with it. And that's it. Is there a question? Okay. So if I'm talking too fast, please let me know. So this is an example. This is an example in Python. It's like, I don't know, like 10 lines of Python or something like that, contrary to like 30 lines in C. So it's good. So that was just the basic details of how to read an OLESS file. Inside the OLESS file is the Office file format. So I'm going to go through the example of PowerPoint, mostly because it's popular and it's the easiest one to explain. So PowerPoint, which is what I'm using now. So PowerPoint stores all of its data, like the slides and all this stuff, inside a stream called PowerPoint document stream. And so to open this stream, all you do is you call open stream. Like, you'll STG open storage the file name, then you call open, it passes back an object, and you call open stream on PowerPoint document. And it passes you back an iStream object, and then you read the data. And the PowerPoint file format also is kind of like a file system as well. It has a container and atom. A container is a directory, and an atom is a file. And the format's also like TLV style. So this is the structure from the PowerPoint. I think this is from the PowerPoint source code. I can't remember. But basically, the way it's a very small structure, and the way you can figure out if a structure, if a record is a container or an atom, is just based on rec version. If it's equal to OXF, then the record is a container. Anything else is an atom. And the record type refers to the PowerPoint specific record types. And these are the records that we document in the file format spec that we released. And so all you do is like you figure out what the number is, and you open up, you download the PowerPoint file spec, which is about like, I don't know, like 400 or 500 pages long. And then you go to index, you figure out, you click on the number, and you go there, and they tell you what it is and how to parse it. This is a picture of it. I drew this using Xfig. So yeah. So it's pretty easy. You have a version, instance, a type, data length, and then more data. This is standard TLV style, which most of you guys should be familiar with. And to parse it, so basically what you do is when you read a stream, the first thing is a header, in which the header is the structure. And then you figure out, okay, is this an atom or is this a container? If it's a container, then it'll tell you that, how much data is there. And then you read the next block, and then you continue, you do it recursively until you've parsed all of the data. I also do this in Xfig, which is pretty cool. And this illustrates how our internal PowerPoint parser works. So it's pretty simple. This is just in case if you decide to write your own PowerPoint parser, and you want to validate if your parser is working correctly or not. This is a picture of what a PowerPoint document looks like. The first thing the first record that you'll typically see is a document container, which is type OX3EA. And inside that container, you have document atoms and an environment, blah, 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 blah. And then you have like slide containers. Slide containers, so each slide in PowerPoint is described using a slide container. So like the header, the footer, all the data, page number, everything is inside the slide. So if you have like 20 slides, you have like 20 slide containers. So that's pretty much it. It's pretty easy to understand. So this is an example, for example, like the document atom, which is the second one on the list, like 3EA. Here it is this is a spec. This is a copy and paste from the official PowerPoint spec. And so this is just a structure. So you just type that out and you read it. That's it. This is a slide atom. They show this. That's what it is. So it's pretty easy. This is an old version of the PowerPoint spec. By the way, if you notice, it's only like 118 pages. This is actually the first version of the PowerPoint spec. These specs are actually updated frequently, sometimes even on a monthly basis. So if you download the PowerPoint spec now, it's like, I think 400 or 500 pages. So, yeah, I know, it takes time. All right, and so parsing. So if you intend to write your own parser, you have to understand that you can't just call, get a file handle and then read it. You can't just do that because it's a file system, just like standard file system, you have fragmentation. For example, if you open up, you edit your PowerPoint slides a lot, it will become fragmented. And obviously, that implies that raw consecutive bytes does not necessarily mean that they're part of the same record, right? So to do it properly, you got to treat it as a stream, an only stream unit. And to do that, I just told you use a COM API, or you can do it manually. You read a header, and then there's a OLE header, and it tells you, how to locate the streams and how big they are. And this is the OLE file format is specified in a different spec, which we also released. There are another one. That one is only like 12 pages. Just in case you don't understand that one, the OpenOffice team has one as well, and that one is like 30-something pages, and it has pretty good, elaborate information on how to implement it. So it's pretty good, and yeah. And the third choice we have is you can integrate all this into a hex editor, so that you can view like the text and you click on it and you say, oh, and the hex editor will tell you what record this is. So there's a hex editor called Hexer by Sebastian. If you're here, yeah. So I love everything about Hexer, with the exception it's written in Java, but it's okay. The cool thing about Hexer is that I actually use it, and no, sorry, that didn't come out right. The cool thing about Hexer is that the cool thing about Hexer is you can actually write plugins to it using either Java or Ruby. Pardon? Python too, I guess. Okay, yeah. I talked to Sebastian a couple days ago, and he said that he'll probably implement some of this stuff in Hexer pretty soon, so you probably don't have to do it yourself. So, yeah. So Hexer is good, you should try it. That's not